Okay, guys, welcome back. So we're gonna continue our quiz 8. So last time we did actually implement the change direction, which is the action, and in the next direction. So these two dictionaries, the next direction contain our preferences for the next grid. Okay. So now let's just think about how we're gonna implement the queue structure. So let's just take a really simple example here. Suppose we start from the top left corner. Suppose we have a 3 by 3 grid here. So the longest path that goes through all the point only once. Yeah, so that's gonna be we have two options. So the first one is probably gonna be a straight ahead, yeah, passing through the first three. And the second one is probably gonna take a turn towards the south. So we have two options here. Obviously, these two have the same length. Then the leftmost is the top one. Okay. So how do we actually get there? How do we actually get there? That is a big question. So let me just show you what I mean. So what the queue is gonna look like. So initially, obviously we have these what's that called? We have this top left corner here, which is one. Obviously, if we draw the queue is gonna be like this. It's gonna be 0 and 0. This is how the initial queue is gonna look like. So actually, if we actually have a look at the QADT here, we can see there's a capacity of 10. So what that actually means is if you do not, if the queue is actually empty, it's gonna be you're gonna look something like this. So basically, it's gonna be 10 of this none, but it is actually empty. Okay, so the very first point is 0 and 0, and now we apply a kind of algorithm to find out the next possible. For example, now we are starting the coming from the west, moving toward the east. Okay, so apply our this preference again. So we're moving towards the east. Okay, and we want to cover what's that called? What is to the right of east? Oh, it's south. Okay, north. So the first one we're gonna put in you know, the queue will be obviously this one, right? 0, 1, the point 0, 1. Because we have nowhere else to go. I mean, the thing want to go right, okay, but you can't. But you can go straight ahead. So it's gonna take this one, right? So now we are in 0, 1, the second grid, and using this preference again, yeah. So before actually doing that, okay, we start with this queue initially, then we actually dequeue. We dequeue, so we actually remove that. So now we are ending up with. Let me just type these things out, okay? I mean, it could be count is a 5 is a 10 exactly, okay? So this is what we started with, okay? Then we add a 0, 0, okay? Then, which is the act of DQ. So we start with this, we NQ, NQ. So means we push a new path into the queue. obviously at this stage the pass is only 1 point. Okay, so we're gonna somehow enqueue this this short pass. Okay, this is how we're probably gonna, so we're gonna end up with this. So now we DQ, yeah, we DQ, and the thing we get out of will once again will be this point, okay, this pass, okay. This is what we get out of. So once again, so now we have a queue that is empty again, okay. This is empty again. So once we have this pass, we actually need to apply a few actions, right? So, for example, we apply this preference. So we are now onto this second grid. So we can say that we append something to it, right? We append a pass to it. We append something to it. And so it's gonna be still on the first row. So it's 0, 1. So this is our most recent pass that has already been explored by the agent. So now what we're gonna do is we're gonna enqueue this pass, right? We're gonna enqueue this new pass into the queue, right? So now what we get is we have something here again. Okay, we have something like this again. We have something like this again. Okay. Then we apply the process of dequeuing. Just take this out. All right, we'll take this out. Yeah, we'll dequeue. We'll take this out. We'll dequeue. So we'll end up with this again. Then, if you have a look at what we have here, right? Then how are we gonna move, right? We are at the second grid, and obviously we came from west moving toward the east. So we want the most favorable direction is turning right. So it will be grid 1, 1 is gonna be this one, right? So we're gonna append this one into it, okay? We're gonna append it to it. Sorry, 1, 1. Okay. However, what is the second most preferable path, which is going straight ahead, which is gonna be this one, right? So if we just take this initial 2 point, append 0 and 2, okay? So this is the two paths we want to enqueue, and we got this top one first, and we got this one the last. So basically we're gonna do 2 enqueue, right? I'm gonna enqueue again over here, okay? Then what we get in the end is something like this. It's gonna be, we have 2 of these, right? We have 2 of these. Okay. So then we do DQ again, right? We then DQ. We're just gonna get these things out, right? DQ, DQ, and so the one we want is this one at the bottom, right? And it's the last to come out of the queue because it was added to the queue the last. First come, first serve, last come, last serve. Okay, that's how it should be. So now it's like thing, we apply this direction scheme again, and we need to find a way to make sure that we will not go back to the grid that we have already visited. So we need to find a mechanism. So all grid. So there's actually three conditions. Three conditions, right? The first is all grids, all candidate grid, okay, needs to be within the boundary, okay? It cannot be outside the grid. And the second one, I mean, is always means all candidate grids must be equal to 1, right? Otherwise, not valid. And the third grid is also really important, and already grids already visited must not be considered for future paths. Okay, so these are the three conditions that we to think about. And now you can see that we are doing this over and over and over again. All right, so we need a loop structure. And what kind of loop? For loop, while loop? Well, you cannot. I mean, it depends on the structure of this queue, whether it is, well, if we have a look here, right? You can have there's the empty, which return a boolean value. See, okay, say that is a great hint there. So what we do? We probably gonna apply a while loop, like something when this queue is not empty or something, or is empty. Okay, so I think is let's just try to apply something here. So we have this nest. We have our first condition, so everything else is gonna be here. And this queue is a class, so we need to create an object out of it, right? So what it can be. So we're gonna name this queue, right? And we have already import all the things we need, right? And it's gonna be creating an object. It's very simple like this. Okay, so we're creating a class, creating the queue class. Okay, the next step probably we're gonna define the starting point, right? The starting point, the top left corner, which is grade 0, 0. So we define starting point, okay? And the starting point is gonna be like this, right? Actually, this is the shortest path we can have, right? It's the shortest path we can have. And we need to add this to the queue, right? So to add things to a queue, we use enqueue. Okay, and there's a dequeue there. So we got everything we need, absolutely everything we need from this file. Okay, it's all good. So now we need to enqueue this single path, the single point into the queue. So we take our object. Sorry, it should be underscore queue with a point. Okay, so it came up automatically. So we do it in queue. So what come in here? Remember each of these paths. Yeah, you need to come with a kind of a directional informations, and we want to have the last direction that we can have. Okay, the very last direction that the agent was heading towards. Okay, so initially obviously we're gonna add something to the starting point, which is the path information, right? Yeah, the starting point. And we need another piece of information inside this list. Okay, and we assume, like in the example over here, we come in from the west. Okay, we come in from the west, moving towards the east. The towards the direction we're moving towards is the one we want. Okay, so we're gonna put east here. I mean, if you have a look at this line is pretty straightforward. It's like I'm gonna turn right, right? I want to turn right. If not possible, I'm gonna go straight. If not possible, I'm gonna turn left. And yeah. So the starting point, the direction can be defined like this. Okay. So we're gonna obviously this means in Q, yeah, in Q, adding first point and its direction to the Q. Okay. Now it's time to define a while loop where we carry out all these. If you look at this text document here, to carry out all these operations here, and so while something, yeah, while the queue is not empty. So what I'm gonna do is I have a look at is empty here. You're gonna return a boolean value. So while this queue is our object, okay, dot is empty. Sorry, there you go. Okay, this one with a bracket. Okay, and the value when it is false. Okay, so we keep dequeuing, remove all these paths from the queue until it is empty. Okay, until it's empty. So we do this option when it is not empty. Okay, this is what we mean here. Okay, so yeah, so what do we do next? We kind of remember that we actually so we have already in queue the first point, which is mean well, okay, we do DQ. So the first step is gonna be DQ, which is over here. So if you have a look at DQ, or remember we actually need to in addition to the past information, we have this direction, which is the last recorded direction. Okay, so we have two pieces of information that we can extract from this DQ, right? I mean, the first one is obviously gonna be the path information, right? It's gonna be path, and the second one is gonna be direction. So we okay, we extract the heading direction out of it. Okay, so once again we take the object, then I just couldn't type on the screen, huh? Okay, so as we have DQ and the parameter take nothing as an argument. So that's that. Okay, so we have a path. So what is now we need to kind of understand exactly where we are, where the agent it is. So what is the last known position of the agent? Yeah. So what is the last known position of the agent? So if we will look at the path here, so it's obviously the last element, okay, the last element of it. So we take, and we already know path is the list, right? The path is the list of tuples. So we take the square bracket, the last one, okay, the last known position of the of the agent. Okay, we got it. So now we need to think about, we know our coordinate positions. We need to apply action to it. And we want to move to the next grid using these directional preference and change direction dictionary, which contain all the actions that can change the current coordinate of our agent. Okay, so we need to find a way to I don't know if you guys, I mean, we have three preferences, right? We need to find a way to loop through them, yeah, one by one. If one doesn't meet the condition, we move to the next one, and it still doesn't meet condition, we then move to the last one. If none of them meet the condition, we stop. Okay, so since we already know what we need to loop through, which is these three elements, right? So we need to kind of find for I in something which is this dictionary, right? Dictionary, and we need to extract this list. Okay, so we um, input the key. Okay, so this is gonna be the key. The key is the directions, right? So the direction, actually we already know the direction with the heading direction there. The heading direction. So the heading direction is gonna come in here. Okay. So here we go. So what do we do inside the loop then? We're gonna move the agent. Yeah. When we move the agent to the next appropriate grid. Okay. And we already know the last known positions, so we define the new position, right? The new position of the agent, and that's gonna give us okay, let me just tie things up. Okay, so we want to change the row number, and we also want to change the column number. Okay, so we want to take our last known positions, yeah, we take the first element, yeah, which is the x coordinate, the row number, then plus the change direction action, right? So the thing that's actually gonna come in here is gonna be I, okay? Because we loop through each of these actions, right? And once we have the value of this action, and we need to get the first element, which is the how x is gonna be changed, how much the x is gonna be changed, which we're gonna make sure that we take the first element. Okay, so that's that. So likewise, to change the column number, you just change this to 1, right? Change the yeah, that's pretty straightforward. So now is how we're gonna decide our preference. Not preference, but yeah, actually it is. We need to decide the preference, whether the one we want to, whether the grid into which the agent want to go to, yeah, actually is allowed and is not obstructed by anything, or is not lying out of the boundary. Yeah, so we want to make sure the next grid we want our agent to move to can be moved into. Okay. So Yeah, so we need to define the set of conditions, and we gonna write some pseudocode here. Okay, we're gonna. Oh, what do I? Sorry for this. I just need to tidy things up. Okay, so we need to define the conditions. So the first one is it says uh, all candidate grade must be within the boundary. Means the next position, the new position, right? The new position, the x, there must be greater or equal to 0, and also it must be smaller or equal to the dimension minus 1. I mean the maximum index number is 9. I mean from 0 to 9, yeah? So it must be smaller or equal to 9, otherwise out of the boundary, yeah? And that's one comparison done. Now we need to do, this is for x value, and we're gonna just copy and paste and change the 0 to 1, okay? And that should be pretty straightforward. So we have completed the first conditions. So that's that. Okay. So inside this if, we're gonna apply our second conditions. So all candidate grade must be equal to 1. So if grade new position 0, which extracts the row number, and we're gonna take the column number as well. I hope you guys can see clearly where we are just make sure we are trying to get the value of that new candidate grade, okay? So if only if it is when it is equal to 1, we then look at the last conditions, okay? The last conditions, which says that grade already visited. Sorry, I missed a not here. Grade already visited must not be considered for further path. Okay, so how do we do that? Actually, it's really simple. Just make sure that next position, yeah, is not in the path. Yeah, path is the list of coordinates. Okay, just make sure the next position you are looking at is not already in the list. I mean, we do not, because we are not gonna, we are only going to go through each of these points once, only once. Okay, so that's what we mean by this. Okay, so now is when we can really do some actions, or like what we have done over here. It's like append. Yeah, remember we have two lists here. Yeah, so we kind of need to make a copy. Okay, make a copy of the original path because we want to grow new point, add the new point to the original path. Yeah, so we need to make two copies or even more, depends on the situations. Yeah, so we need to make a path list. I mean, this is gonna be the path copy because we do not want to alter the original path. Yeah. So, and this path list is actually gonna be the one into which we're gonna append new point values, the new path value. Yeah, the new point we have just explored using the agent. Okay, so I append this, what's that, the next position. Sorry, not next, new positions. Okay, new positions. New positions, new positions. Okay. And the thing that we want to include will be the path list, right? The path list and the directions. Yeah, remember we have already, you know, had a look. We have already looked at the direction. How these I represent the directions. Okay, so now we include everything. Yeah, this Q, our original object, are gonna include, and we're gonna just put to be included, the things to be included over here. Okay, I think that is how we implement this function. Actually, the the very last step is simply to return a path. Okay, it's simply to return a path. So because we know the last path to be extracted from the queue is gonna be the one that is the leftmost, because it is the one to be added to the queue the last. Okay, so we're gonna let's just tidy things up. Okay, so I just wanna check everything is alright. Okay, let's just restart the kernel. Okay, I'm gonna Control A and Shift Enter to execute. What? We have invalid syntax. What happened? Something went wrong. Uh, Hmm. So guys, sorry about this, but I probably need to debug this thing and try to find a way to. So I'm gonna pause there, and we're gonna maybe see you again later once I got the problem solved. See you later.